Hello everyone, I am Hiba. Today I will be describing iterative methods. There are two types of iterative methods, Jacobi iterative methods and Gauss-Seidel methods. Iterative methods are indirect methods. We start with an approximation to the true solution, and by applying the method repeatedly, we get better and better approximation till accurate solution is achieved. So first we will look what is Jacobi method. We have an equation, suppose a1x plus a11y plus a13z equals to b1, a21x plus a22y plus a23z equals to b2, and a31x plus a32y and a33z equals to b3. So what we'll do, first we will subject x, y and z. What are the criteria? We will assuming x equals to 0, y equals to 0 and z equals to 0 as our first approximation. Then we will repeat the process until we get two successive operations are equals or nearly equal. Condition, what are the conditions? First condition is the coefficient of the leading diagonal must be larger. If not, then we will rearrange our equation to get the larger one on top. So for example, we have a question, 4x plus 5 plus 3z equals to 17, x plus 5y plus z equals to 14, 2x minus y plus 8z equals to 12. First, what we will do, we will subject x, y and z. Okay, what this n and n minus 1 showing? This is like if we are going our first iteration, then x equals to 1. This will becomes x naught and z naught, and so on. For y1 it will becomes our x naught and z1. For z1 it will becomes our x naught and y naught. We will take this x naught, z naught and x naught 0 for our first iteration. By plugging these values over there, we will get our first x1, y1 and z1, our first iteration. Then we will use these values of x, y, z for our second iteration. We get x2 equals to 97 by 40, y2 equals to 33 divided by 20, and z2 equals to 63 divided by 80. We can see there is a huge difference between previous value of x, y, z and these values. We will repeat our procedure again. Now we will take x, y and z as 97 by 40, 33 by 20 and 63 by 80. We will plug this in our equation to get our third iteration. We get x3 equals to 3.25, y3 is equals to 2.16 and z3 is 1.1. There is, we can say, okay, this is again there is a large difference between previous values and these values. So we will iterate it again by taking these values of x3, y3 and z3. But for the result of 4 iteration comes x4 equals to 2.885, y4 1.93 and z4 0.96. Again we are seeing, okay, there is a difference, but we can see there is not a huge difference as before we were getting. Z4 is like close to z3 and y4 is close to z2. Let's see, x2 is also closer, so but it's not accurate, it's not near, so we will try to do another iteration. We do another iteration. Let's see what happens when we repeat the process again. We use x, y, z, plug in our equation, and we get new values of x, y and z. X equals to 3.05, y equals to 2.03 and z5 equals to 1.05. These values are for fifth iteration. Okay, then we did the process again, simple process. We plug these values in the equation and we get the values of x6, y6 and z6. You can see there is no difference between the previous values of x, y and z and the new values of x, y, z. Hence we can conclude that this is our final equations. These are final roots. Thank you for watching.